Alrighty, so these are going to be our notes for section 21-1. We're going to blend together chapter 20 and 21, and then we are going to be taking our test the week right before spring break. So kind of keep that in the back of your mind. So section 21-1, special right triangles. Alrighty, so with special right triangles, we're going to spend at least 2 lessons today and then Monday talking about the 2 different types of special right triangles. And I anticipate review then next Thursday. So we have a particular kind of special right triangle called the 45-45-90. So here's what I need us to do. I need us to draw a right triangle, and don't draw it just with one little line on your notebook paper. It's going to be too small. You need to be able to write inside that triangle. So I'm going to draw mine so that it is 4 lines tall. And I'm going to tell you it's a right triangle no matter how good or bad I draw. And I'm also going to tell you something else. I'm going to tell you that this is what we call an isosceles triangle. And I think we've talked about this first semester, and I know you guys have talked about it in previous math classes, but it's been a long time. Does anyone happen to remember what it means to be an isosceles triangle? Go for it, Ethan. Okay, so in an isosceles triangle, we have 2 congruent sides. Now there's something else in an isosceles triangle that's also the same. Want to make a guess what that other thing would be, or other 2 things would be? The angles. We're also going to have 2 congruent angles. So this special right triangle, it's a right triangle. I'm telling you that because I've got that right angle right here in the bottom left corner. And I'm also telling you that this triangle is isosceles. So that means that these 2 little angles, they have to be the same. So we need to go figure out how big those angles are. Okay, can someone help me? How many total degrees, if I were to add up all 3 angles in a triangle, how many total degrees in a triangle? 180. So we have 180 degrees in this triangle. We've already used 90 with the right angle. So that means we have 90 degrees left. And these 2 angles are the same, so I have to split that 90 degrees equally. The other angles in this triangle are 45 degrees. So I need you guys to write that in this triangle. So that's why we call it a 45-45-90. You've got 2 equal angles. They must be 45 degrees. And then a right angle, because it's the only way that we can have 90 degrees on the right angle and 2 equal angles to make 180 degrees. Now the next thing I need you guys to mark, we've talked about the 2 congruent angles, but we're going to have 2 congruent sides. Would you mark the left and the bottom with one single slice through mark? What we're doing is we're saying that those 2 legs are the same length. Do you need a pencil? Is that what you're searching for? Do you need a pencil?
Oh, no.
Okay, I wasn't sure if you were searching for one or not, because I always have pencils if you need it. Okay, so this is what's special about this 45-45-90. We've got 2 congruent legs. Opposite the 90 degrees, would you guys label that as your hypotenuse? Because that's what it always is, no matter how special or not special this right triangle is. Okay, so here's going to be our task. What we're going to do is we're going to do a series of examples, knowing that these are 45-45-90s, isosceles right triangles. And we're going to see if we can figure out a pattern on how to figure out the length of the hypotenuse. So our example, the directions are going to be find the missing side. And the first ones that we're going to do, thinking about my last class with hypotheses, the first ones we're going to do are going to be the hypotenuse. That's going to be the missing side. So the next set of triangles that we draw, they don't have to be quite as big because we're not going to write as much inside them. So you're going to notice that I'm just going to do 2 lines tall for this next triangle to save a little bit of my paper space. And I want you to mark that those 2 angles that are not 90 degrees each get 1 loop because they're the same size. And I want you to mark the 2 legs with 1 tick mark each because they're the same size. Now, let's do some labeling. I want you guys to mark the left-hand leg as 5. And I want you to mark the bottom side as A. And I want you to mark the hypotenuse as X. You were expecting a C, weren't you? No, I wanted to mix it up on you. Okay, right now, without doing any math, do we know how big side A is? Show me with your fingers. It's not a 1. Don't you flip me off. Come on. Oh, yeah. I'm seeing everybody's waving high. It's a 5. This has to be 5 because in this type of a triangle, both of the legs, the pieces that make the right angle, they are the same. No effort needed, right? The effort is going to come with the X. Now this is a right triangle, so let's do Pythagorean theorem. Let's do 5 squared plus 5 squared equals x squared. We're going to use Pythagorean theorem to go find the length of our hypotenuse. And I'm going to be your little human calculator. 5 squared is 25, and another 25. And when I add those 25s together, we'll get 50. So I'm hoping that's making sense. I'm going to pause, and I need to know if you guys have questions on this so far, because we are not done. Okay. We need to do a square root. And this is what we had been practicing. Now, can the square root of 50 break down? Yeah, can you give me 2 numbers that multiply to make 50? 10 and 5? Let's do those. So let's break that down into a 10 and a 5. The 5 is prime, so I'm going to circle it. The 10 breaks down 2 and 5. So this is the square root of 2 times 5 times 5. And so this is what we had practiced for about a week. The square root of 5 comes out. The 2 stays. So we just figured out that the length of this missing hypotenuse, it's not showing up very well with the highlighter, is 5 root 2. Interesting. It has the 5 from the other 2 legs in it and a root 2 added on the end. Questions on that example? Because no, we are not done. Okay, let's do another one. So I'm going to flip my paper over because I don't quite have enough writing space. So we're going to draw another right triangle. Made this one a little bit bigger. I made it 3 lines long. And let's choose, actually you guys can choose a number. I don't want a 1, that's kind of boring. Choose a number, whole number, positives. Not a 1, not a 5. Give me a number. 4. So I'm going to tell you that this top leg is 4. I'm going to mark it so that you know those two legs are the same. I'm going to label my hypotenuse as X, and I'm going to name the other leg B. So our job is to go find the missing sides. Guys, right now, can you tell me what B is? 4. So take the freebie, knock that one out, be done with that guy. But let's do Pythagorean theorem, and let's go find the length of our hypotenuse. So we're going to take leg squared plus leg squared. If you're like, but how do I know which one's which? Remember that the legs come together to make the right angle. The hypotenuse is opposite the right angle. We're going to set that equal to x squared. And again, I'm going to be your human calculator. So 4 squared is 16, and another 16, and we have our x squared. And 16 plus 16 is 32. And we know we have to take a square root so that we can figure out what x is equal to. So I'm going to pause before I go any further. Let me know if you have any questions before we break down the square root of 32. Okay, I need two numbers that multiply to make 32. This guy breaks down. 4 and 8. 4 breaks to 2 and 2. 8 breaks to 2 and 4. And the 4 breaks again. So we have a hot mess of 2s. Got 1, 2, 3, 4, 5 of them. So remember what square roots do. They pull out a pair, and then another pair, and we end up with 4 root 2. So a 4 came out, and a 2 stayed in, equal to x. So I need to know if you have any questions on simplifying the root, because I'm going to try to see if we've just recognized a pattern. When we look at what x is equal to, it's 4 root 2. The length of the leg is there, and then we added an extra root 2. Did you guys see that happen on the previous problem as well? It was down there, leg with a root 2 for the hypotenuse. Are you guys seeing this pattern? That pattern is the same every single 45, 45, 90. So let's do another one. I need someone to give me a number. I don't want a 1, a 4, or a 5. Give me any number you want. 7 works. So I'm going to tell you that the left-hand side is 7. And I'm going to label the other leg as A and the hypotenuse as C. Give you guys a second to catch up with all the writing and drawing here. Right now, can you tell me what the length of A is? 7. It's got to match. And right now, I can tell you without showing any work that the length of C is 7 root 2. The pattern shows that I keep the leg and I throw a root 2 on the end. And if you're like, are you sure you're going to question your math teacher? You should. You should question your math teacher. 7 squared plus 7 squared equals c squared. And you don't have to write this down. You can just watch because I'm going to fly through it. That's 49 and 49. And that's 98. 98 is 49 times 2. Guys, the square root of 49 is 7. This pattern is going to hold. It's always going to be leg root 2 to find your hypotenuse. So let's write that down generically. If we have a 45, 45, 90 triangle. The two legs, once that clears up, look like it's going to clear up. The two legs are going to be the same because it has to be. They're the same. It's 45, 45, 90. And your hypotenuse will be the length of the leg times root 2. Every single time. Questions on that generic one? Let's do one more, and I'm going to make it a big number this time. So last example of this style. So again, mark it so that we know it's a 45, 45, 90, that we've got two congruent legs and two congruent angles and a right angle. So you guys are going to help me with this. I want whole numbers, positives, no decimals, no fractions. Someone shout out a number. I don't care what number it is. 60? 16. So I'm going to do a 1 and a 6. I need some more numbers. Give me another number. 32. So I'm going to tell you that the length of the top side is 1,632. And you're probably thinking, ooh, Ethan, why'd you give her that number? Because she kept asking for numbers. That's why he did it. What's the length of the right-hand leg? It's the same. It's that number, 1632. And without doing any math, because the pattern holds, the hypotenuse is 1632 root 2. Done. Every single time on a 45, 45, 90, the hypotenuse is root 2 times the leg. Write that down. And this is for a 45, 45, 90 triangle. The hypotenuse is root 2 times the leg. Every single time. No more math needed. Follow a pattern. I'm going to show you another pattern once you guys get caught up with your writing. And I'm going to have to flip the page to do it. It's still 45, 45, 90. But we're going to look at it from a different direction. Just making sure everybody's had enough time to write this down. Does anyone need any more time to continue writing down this part of our notes? Okay. So, new set of examples. We're going to find the missing sides, but this time we're solving for legs. And there's still 45, 45, 90 triangles. So let's draw another right triangle. Mark it so that you know it's 45, 45, 90. And I'm going to choose the numbers for these because I want to take us down a certain pattern and path. So I'm going to tell you that our hypotenuse is 8. And I'm going to mark both of the sides as x because they're the same. So they should have the same variable label. So we need to do Pythagorean theorem. Well, we're going to take our leg squared and our other leg squared. We don't know what either one of them are because they're the same, x squared. And we're going to set that equal to 8 squared. Now we've got a little bit of algebra we have to work through. X squared plus x squared, that's 2 of them. So that's 2x squared. Oops. And I'm going to change 8 squared to be 64. Now we need to solve this equation, so we need to divide away that coefficient, that multiplier of 2. So we'll have x squared equals 32. Again, I'll be your human calculator. And then we have to take a square root. And so I'm breaking down that 32, and we broke down 32 just a couple of minutes ago. It's a hot mess of 2's. So out comes a pair, out comes another pair, in stays a lonely little 2. And we just figured out, oops. That's why math teachers don't usually use pens. We make mistakes. Hang tight, Taylana, or was it a stretch?
No, I have a question.
Hang tight. Okay, so when we break that down, we get 4 root 2. Now go. What's your question?
What happens when you have one as a fraction?
We'll get there. That's a good question. Not yet. We'll get there. Okay, guys. Are we okay with the 4 root 2 coming out of the 32? Because we had just done it. So I want you to take a look at the pattern. There's a pattern here. Each one of those legs is 4 root 2. Okay, 4 and 8. If I cut 8 in half, I get 4, don't I? And we stuck a root 2 on it. Let's see if there's something with that. Let's do another one. Let's draw another right triangle. I get tired of drawing these guys. Mark it as a 45, 45, 90. And this time our hypotenuse is 10. And I'm going to label both legs as A because they're the same. Okay, let's walk through this. Let's do a squared plus a squared equals 10 squared. A squared plus a squared, that's 2 a squareds. And 10 squared is 100. And let me know if I'm going too fast for you. So we're going to divide away our 2. And we'll get a squared equals 50. And so we're going to take our square root. And I'm going to start to break it down. Let you guys catch up to me. Taylon, I haven't forgotten about your question. I'm just not ready yet, but I will get there. You guys doing okay with the 2 times 5 times 5? Out comes a pair of 5s. In stays the 2. So we should, if I can zoom out enough, be able to recognize that, hey, the legs are half the hypotenuse with a root 2 added. Interesting. Let's write that down. If we have a 45, 45, 90 triangle, if I know the hypotenuse, sorry you guys couldn't see that at all, if I know the hypotenuse, I can find the leg. The leg is half the hypotenuse times root 2. So if I know the hypotenuse, it's half the hypotenuse root 2 to give me the leg. So we're going to do a couple of those. And Taylana, in a few examples, I'm going to get to that fraction situation.
Yeah.
Okay, I'm out of room. You got it. All right, flip that paper over. So let's draw another 45, 45, 90 triangle. There we go. So I want our hypotenuse to be 20. I'm not going to do Pythagorean theorem to go find the other two legs. I have a pattern. The pattern says that I can take half my hypotenuse times root 2. That's going to tell me my leg. My hypotenuse times root 2 divided by regular 2. So 20 over root 2, or excuse me, 20 times root 2 over 2. So I know my hypotenuse. I'm going to cut it in half, and I'm going to stick a root 2 on the end. I just found the leg. Now that was all well and good for an even number, right? What if it's not an even number? What if we draw another 45, 45, 90 triangle, and I tell you that the hypotenuse is 9? I have to go find the legs. I need to go find B, because I feel like calling them B this time. We can do that. It's the hypotenuse with a root 2 over a 2. And you walk away. Hypotenuse times root 2 over 2. Now, Taylana asked me a different question about a zillion years ago. How do we deal with fractions on these? Draw another triangle. Now, it's important that we recognize this pattern only works for 45, 45, 90s. And so let's go with, 4 over 15 for my hypotenuse. Like, there's a fraction for you. Then our leg is going to look a little weird. Write down your 4 over 15, and I'll pause to give you guys time to catch up in the writing. Stick a root 2 on the back end, because it's times root 2. And you know how we're going to cut the number in half? Well, there's different ways to write the concept of 1/2. We can divide by 2, or we can actually multiply by 1/2. That keeps the 2 on the bottom. Well, we could reduce the 2 and the 4, and it gives us 2 root 2 over 15. So to answer Taylana's question, when we say the leg is the hypotenuse times root 2 over 2, we could also call that half the hypotenuse times root 2, because to divide by 2 is a half. Did that answer your question and make sense?
Yeah.
Awesome. And thank you for waiting for that. You can see why I didn't want to start with that one.
Yeah.
We needed to build our way up. Okay, so I'm going to pause real quick. We're almost done. Do you have questions on any of these examples because we're going to write down a little summary. All right, here comes our summary. You're welcome. So for our summary, draw our last 45, 45, 90 of these set of notes. And so we're going to kind of break it down. If I know the leg, my hypotenuse is leg root 2. If I know my hypotenuse, then the leg is hypotenuse root 2 over 2.